Hello everyone and welcome to Mentor's Galaxy. I am Pratiksha Roy, your chemistry mentor. The topic of today's discussion is empirical formula and molecular formula. ये एक बहुत ही न्यूमेरिकल बेस्ड टॉपिक है एंड इससे आप क्वेश्चंस एक्सपेक्ट कर सकते हो नॉट ओनली इन योर कॉम्पिटिटिव एग्जाम्स बट ऑल्सो इन योर स्कूल एग्जामिनेशंस. Class 11 students, this topic is very important for you. This topic is from the chapter of some basic concepts in chemistry and इससे आप अपने स्कूल के एग्जाम्स में क्वेश्चंस जरूर एक्सपेक्ट कर सकते हो. So it is a very important chapter and it is very interesting and easy to learn. So let us start today's discussion on empirical formula and molecular formula. So the key points of today's discussions will be the definition of empirical formula and molecular formula, the significance कि हम क्यों पढ़ते हैं उनको, उनका क्या सिग्निफिकेंस है, व्हाट इज देयर इम्पोर्टेंस, एंड लास्टली मोस्ट इम्पोर्टेंटली न्यूमेरिकल प्रॉब्लम्स जिससे आप क्वेश्चंस एक्सपेक्ट कर सकते हैं. सो लेट अस बिगिन. So our first question should be, what is a molecular formula? What is the definition of a molecular formula? Molecular formula depicts the exact number of different types of atoms of elements present in one molecule of a compound. So molecular formula will give us the exact number of different type of atoms of elements that is present in one molecule of a compound. कि एक कंपाउंड में कितने सारे एलिमेंट्स है, उसे कितने सारे एटम्स कितने अमाउंट में प्रेजेंट है, दैट विल बी गिवन बाय द मॉलिक्यूलर फॉर्मूला. It shows the actual number and the types of atoms in a molecule and it is the real formula of a compound. So molecular formula is the real formula of a compound. ये हमको बताता है कि उस कंपाउंड में कितने सारे एलिमेंट्स है, उस एलिमेंट्स के कितने सारे एटम्स है and everything about the compound. So it is the real formula. It gives the actual number of the atoms that is present. And lastly, molecular formula is crucial in the calculation of molar masses of any compound and for determining the percentage composition. तो इसको हम क्यों यूज करते हैं? क्योंकि इससे हमें मोलर मास निकालना होता है या फिर परसेंटेज कॉम्पोजिशन भी हम डिटरमाइन कर सकते हैं. So we absolutely need the molecular formula to know about the compound that we are dealing with. क्योंकि अगर molecular formula नहीं होगा तो हमको पता नहीं चलेगा कि उस molecule में कितने सारे atoms है, कौन कौन से elements है and everything about the compound. So molecular formula is the real formula of a compound and it is used for the calculation of molar mass and also to determine the percentage composition. Let us see some simple examples. Here I have taken names of some compounds and their molecular formula. So here I have glucose and the molecular formula for glucose is C6H12O6. यहाँ से हमको पता चल रहा है कि ग्लूकोज के एक मॉलिक्यूल में 6 कार्बन एटम होंगे, 12 हाइड्रोजन एटम होंगे एंड फिर से 6 ऑक्सीजन एटम होंगे. So this is the real formula. Molecular formula is the real formula. Next compound is carbon tetrachloride, which is CCl4. This is actual formula. एक carbon and 4 chlorine. Then we have calcium carbonate, which is CaCO3. एक calcium, एक carbon and 3 oxygen. Sodium zincate, which is Na2ZnO2. 2 sodium, 1 zinc and 2 oxygens. And acetic acid, which is CH3COOH. 1 carbon, 2 carbons in total, 4 hydrogens in total and 2 oxygen. So these are some very common compounds, glucose, acetic acid, these are very common compounds. Similarly, carbon tetrachloride, calcium carbonate, sodium zincate शायद थोड़ा uncommon है, but it is still a very important compound. And the molecular formula of these compounds I have mentioned. So they are the real formulas of these compounds. So these are the molecular formula. अब molecular formula तो हो गया. So let us move on to the empirical formula. So what is an empirical formula? Empirical formula gives the proportions of the elements present in a compound but not the actual number or the arrangement of atoms. मतलब empirical formula molecular formula का एक part है but it is not the real formula. It will give us a ratio of the elements that is present in that compound. It will give us the ratio of the atoms. It will not give us the exact number of atoms that is present in the compound, but it will give us a simple ratio in which the elements are present in that compound. It represents the simplest whole number ratio of different atoms present in a compound. Simplest whole number ratio of the different atoms which is present in the compound. Means it will not give us the exact number of the atoms or the elements, but it will give us a ratio of the different atoms that is present in the compound. And the most important point, empirical formula is not the real formula. The real formula of a compound is the molecular formula. Empirical formula will just give us a ratio. It is not the real formula of a compound. So to understand empirical formula, let us see some more examples. Here I have made a table. इसमें मैंने कुछ compounds लिए हैं. इसके molecular formulas भी मैंने दिया है and empirical formulas भी I have put for the correct comparison. So let us see, our first compound is glucose. We studied in the previous slides that the molecular formula of glucose will be C6H12 and O6. अब इसका अगर simple ratio निकाले तो we will get the empirical formula which will be CH2O. मतलब यहाँ पे हमारा common factor है 6. If you multiply all the atoms by 6, you will get the molecular formula. So if you divide this by 6, you will get the simplest whole number ratio, which is CH2O, which is the empirical formula. So empirical formula is not real. Empirical formula is not real formula. It will just give us a ratio to understand that what atoms might be present in the compound. तो यहाँ पे ग्लूकोज के लिए हमारा कॉमन रेशियो हो सकता है 6. So if you multiply this by 6, you will get the molecular formula. The next compound will be hydrogen peroxide. जिसका molecular formula है H2O2. And if you take a common factor of 2, you will get the empirical formula which is HO. Next is ethane, which is C2H6. Again, if you take a common factor of 2, you will get CH3, which is the empirical formula for ethane. उसके बाद आता है water. The formula is H2O. As you can see, there is no common factor to be taken. So the common factor in this case will be 1. So for H2O, the empirical and the molecular formula are the same. They are the equal. But in other cases where you can take a common ratio, then the molecular formula and empirical formula will be different. So for water, the common ratio is 1. So molecular formula is also H2O and empirical formula is H2O as well. Lastly, we have diborane whose formula is B2H6 molecular formula. Again, the common factor here will be 2. So now we have the empirical formula of BH3. So this table explains the difference between molecular formula and empirical formula. If we take out a common ratio, then what we will obtain is the empirical formula. This is not the real formula. This is just a ratio of the atoms that is present in the actual molecular formula for the compound. So I hope from this table, you have a clear idea about what is molecular formula and what is empirical formula. Now we will see the relation between a molecular formula and empirical formula. There is a simple relation between these two formulas. This is the real formula, which is the molecular formula, and empirical formula, which just gives the ratio of the atoms. So the relation is N equals to molecular formula mass or molar mass divided by empirical formula mass. This is a very, very important relation where N is the common ratio. I'm writing it as CR, common ratio N will be equal to molecular formula mass, which can also be written as the molar mass divided by empirical formula mass. So this is the relation between a molecular formula and an empirical formula for any compound. Let us see a very simple example. I have taken a compound which is ethane. So we know the molecular formula, we saw it in the previous slides also, it is C2H6 and the empirical formula is CH3. These are very simple formulas, so we can understand that the common ratio will be 2. But if you want to solve it using this relation, let us see how to do it. So we have to find the molecular formula mass and the empirical formula mass. It is quite easy. So for ethane, the molecular formula mass will be 12 into 2 because there are 2 carbons, and 1 into 6 because there are 6 hydrogens. So if you just solve this, it will be 24 plus 6, which will be 30. And for the empirical formula mass, it will be 12 because there is 1 carbon now, and 1 into 3 because there are 3 hydrogens now. So it will be 15. So we have our molecular formula mass, which is 30, and empirical formula mass, which is 15. So now if we just divide them according to our formula that we studied in the last slide, we will get 30 by 15, which is equals to 2. By just seeing the molecular formula and empirical formula also, we understood that हमारा जो common ratio है वो 2 ही आएगा. But if you want to solve it like this using the molecular formula mass and empirical formula mass, you can solve it and it will give you the same answer of 2. So this is the formula for the relation between a molecular formula and an empirical formula. ये relation सारे compounds के लिए applicable है. So this is the final relation. Now we will know about the significance कि ये molecular formula और ये empirical formula हम क्यों पढ़ते हैं, इसके बारे में जानना जरूरी क्यों है. So molecular formula is crucial in the calculation of molar mass of any compound and for determining the percentage composition as it depicts the actual formula of a compound. इस स्लाइड में मैंने जैसे मीथेन का मास निकाला, मुझे मीथेन का फॉर्मूला पता था इसलिए मैंने ये 30 वैल्यू में निकाल पाई. बट इफ I had not known what is the molecular formula, would I have been able to calculate this mass? No. So to calculate the molar mass of any compound and for determining percentage composition, which is a separate topic, it requires the molecular formula. We need the actual formula of any compound to make various types of calculations. So why do we need empirical formula? क्योंकि molecular formula ही important है because that is the real formula. Empirical formula का क्या use है? Empirical formula is used to make calculations simpler for certain compounds which have large number of atoms, especially organic compounds. Organic compounds में बहुत सारे atoms होते हैं, like long chains of carbon, a lot of number of hydrogens. So they make calculation very complex. But if we know the empirical formula, the simple ratio, it will make our calculation much easy. We will just calculate using the empirical formula and then we will just multiply the common ratio. So empirical formula is used to make calculations easy for big compounds like organic compounds. Compounds which have a large number of atoms, जिसमें बहुत सारे atoms होते हैं, they make the calculations difficult. So to make them easy, we need the empirical formula. So molecular formula we obviously need because it is the real formula. Empirical formula we additionally learn to make our calculations easy for complex compounds. So this is the significance of molecular formula and empirical formula. Now we will move on to the most important part of this topic, which is the numerical problem. That is very important for your exams. ये numerical problems ही आपके exams में आते हैं. And in your school exams, we come for like 4 to 5 marks. So अगर आप इनको अच्छे से solve कर पाए, you will get guaranteed 4 or 5 marks. So let us learn the steps to solve numerical problems based on empirical and molecular formulas. Steps होते हैं उनको solve करने के लिए, we will now learn them. So let us take a question for example. The compound contains 4.07% of hydrogen, 24.27% of carbon, and 71.65% of chlorine. Its molar mass is 99 grams. Find its empirical and molecular formula. So let us see what is provided in the question. कुछ हमको elements दिए गए हैं जैसे कि hydrogen, carbon and chlorine. So we have been given 3 elements. तो इस compound में हमारे पास होंगे carbon, hydrogen and chlorine. We have to find out the number of these atoms कि कितने amount में ये present होंगे इस compound में, जो compound हमको निकालना है. So we are given the percentages also, which is 4.07% of hydrogen, 24.27% of carbon and 71.65% of chlorine. So we are given the percentages of these three elements and we are given the molar mass. Molar mass is basically the molecular formula mass. Molecular formula mass is 99 grams. So we have to find the empirical formula and molecular formula also. So let us see the steps which is required to solve this question. The first step is conversion of mass percent into grams. Considering the mass of the compound to be 100 grams, we convert the mass percentages into grams. तो हमारा पहला काम होगा ये जो percentages है उसको हमें mass में convert करना है. वो हम कैसे करेंगे? We will consider the mass of the compound, the total mass of the compound to be 100 grams. And then we will convert the mass percentage into grams. So 4.07% of 100 will be 4.07 only. X percent of 100 will always be X. This is very common because X percent is basically X by 100 into 100 will be X. So these percentages will just remain same in the value, but we will just convert them into mass. So for hydrogen, the mass will be 4.07 gram. For carbon, it will be 24.27 gram. And for chlorine, it will be 71.65 gram. So we just simply converted the percentages into masses. It will be of the same value because we are considering the mass of the compound to be 100 gram. किसी भी क्वेश्चन के लिए आपको 100 grams कंसिडर करके ही ये फर्स्ट कन्वर्शन करना होगा. So this was our first step. We just converted this into mass. Now let us look at step number 2. Calculating the number of moles of each element. This is a very important step. The obtained masses are divided by the atomic masses of the respective elements to find the number of moles. तो number of mole निकालने के लिए हमको क्या करना होगा? We have to divide the obtained masses, जो mass हमने यहाँ पे निकाले, we have to divide them by the atomic masses of the elements to find the number of moles. So in the second step, we have to find the number of moles. So let us do it. So for hydrogen, it will be 4.07 and hydrogen का atomic mass होता है 1. So it will be same only 4.07. Hydrogen का हो गया. Now we will do for carbon. It was 24.27. We will divide it by carbon का कितना होता है atomic mass? It is 12. It will come out to be 2 point something because 12 2s are 24. So if you calculate, it will be 2.022 So this will be the value. We will just consider up till 2 decimal places. That will be okay, not a problem. And now we will do for chlorine. So for chlorine, we will divide 71.65 divided by the atomic mass of chlorine is 35.5. This will also come out to be around 2.0 something. So it will be 2.01. I think it will be 8. आप लोग भी calculate करके देखिएगा. I hope your values will match with mine. So we have found the number of moles. So this one was very simple. This will be 4.07 only because it was just dividing by 1. If you do this division, it will come out to be 2.0225. And this division, it will come out to 2.018 and more values. We will just consider up till 2 decimal places. That will be fine. So now what we will do, we will just move on to step number 3. So in the first step, we converted the percentages into mass, and in the second step, we divided the mass by atomic mass to find the number of moles. So now let us see what the third step suggests. So the third step is very important. Each of the mole values are divided by the smallest value among them. मतलब ये जो 3 वैल्यूज हमने यहाँ पे निकाले, इनमें से सबसे जो कम वैल्यू होगा उससे we will divide all the other values. This step is done to find the ratio of the atoms. अब हम धीरे धीरे empirical formula की तरफ बढ़ रहे हैं because we now finding the ratio of the atoms. If the ratios are not whole numbers, they are multiplied with a suitable coefficient. ये एक extra point है. अगर आपका डिवाइड करने के बाद 1.5 या फिर 2.5 ऐसा कुछ निकला, so we have to multiply them with a suitable coefficient, which is usually 2, because if you multiply with 2, they'll come out to be whole numbers. This will come out to be 3 and this will come out to be 5. So this is an extra step. We will see if we do not get a whole number, then we will multiply with a suitable coefficient. So this is a very important step to find the ratio of the atoms. जो सबसे कम वैल्यू हमको मिला है प्रीवियस स्टेप में, नंबर ऑफ मोल्स का जो सबसे कम वैल्यू है, वी विल डिवाइड दैट वैल्यू टू द अदर वैल्यूज. मतलब यहाँ पे हमारा सबसे कम वैल्यू ये है, विच इज 2.018. So we will just divide this value with all these values. So we will divide all these values with lowest value. So we will now consider the whole numbers in this case. ये जो decimals है, we can ignore, because if you round them off, it will come to be 4.1, which will be 4. This will come out to be 2 only. 2.02 means 2, and this will also come out to be 2, which is 2.018. It will also be 2. So for our easy calculations, we will just consider as the whole numbers. It will be helpful for us. So now we will do for hydrogen, we will do 4 by 2, which is 2. For carbon, we will do 2 by 2, which is 1. And for chlorine, we will again do 2 by 2, which is again 1. अगर आप चाहो तो आप सारे मोल्स जैसे आपने निकाले थे उससे भी डिवाइड करके फिर आप राउंड ऑफ कर सकते हो, बट आई हैव राउंडेड ऑफ इट इन दिस स्टेप ओनली. It will be better if you divide this exactly how you found it and then you round off. Then the chances of mistakes will be less. But if you see that the rounding offs are easy, like it will come 4 only. If I round off this one, it will be 4.1. 4.1 is 4. This is 2.02. Even if I round off, it will be 2.02. So it is 2. And 2.018 is 2.02, which is 2. So if you see that you have no क्वेश्चंस वाइल राउंडिंग ऑफ, कि राउंडिंग ऑफ करते वक्त आपको कोई कॉम्प्लिकेशन नहीं मिल रही है, तो आप राउंड ऑफ कर सकते हैं, बट फॉर सेफ्टी यू कैन राउंड ऑफ लेटर ऑल्सो आफ्टर दिस स्टेप. सो इन दिस स्टेप वी आर गेटिंग होल नंबर्स डायरेक्टली. हमें ऐसे 1.5 2.5 का कुछ मिला नहीं है. सो वी आर गेटिंग 2 1 and 1. सो द रेशियो ऑफ hydrogen is to carbon is to chlorine, we have gotten 2:1:1. So this is very important, this ratio. So we have gotten the ratio after division. And if we had gotten any decimal like this, हमें बस एक suitable coefficient से multiply करके उसको एक whole number का रूप देना है. But we did not get in this question. So we have just gotten our whole numbers, which is 2:1:1. The fourth step is the empirical formula can be written according to the whole number ratios calculated in the previous step. तो इस स्टेप में जो रेशियो होल नंबर रेशियो हमने निकाले हैं उस हिसाब से हम एम्पेरिकल फॉर्मूला को जस्ट सिंपली लिख देंगे. सो इट H was 2, carbon was 1 and chlorine was also 1. So the empirical formula will be CH2 L. You thought that why did not I write H2CCl? This is not wrong, but this is conventionally written. अगर आप कोई organic compound देखोगे तो ऐसे ही लिखा जाता है. That's why I have written like this. But this is also not wrong, but you should write it in the conventional way that it is written. So हमारा empirical formula हो गया CH2Cl. जो रेशियो हमने निकाला, सिंपली हमने वो रेशियो यहाँ पे पुट कर दिया. एक कार्बन था तो एक कार्बन, दो हाइड्रोजन थे दो हाइड्रोजन एंड एक क्लोरीन, सो 1 क्लोरीन. CH2Cl is our empirical formula. So we have found the empirical formula. We have completed one part of the question. So अगर आप इतना भी कंप्लीट करते हैं तब भी आपको पार्ट मार्किंग जरूर मिलेगा. बट अगर हम इतनी दूर आ गए हैं तो मॉलिक्यूलर फॉर्मूला बस एक सिंपल से कैलकुलेशन से निकल जाएगा. So let us learn that. The fifth step, using the empirical formula mass and the molar mass N can be calculated. From N, the molecular formula can be obtained. So we will use the relationship that we studied between the molecular and empirical formula, and उससे हम N की वैल्यू अगर निकाल ले तो हमको molecular formula भी मिल जाएगा. So let us see. Okay, we have the molar mass. This will be 99. This will be 99 grams. So we have the molar mass, which is 99 grams. So N का क्या फॉर्मूला था? N was equal to molar mass of the molecular formula mass divided by empirical formula mass. तो ये है हमारा 99. But what is this? So let us find out. Very simple. Our formula was CH2Cl. Was CH2Cl. So it will be 12 plus 2 into 1 plus 35.5. एक कार्बन के लिए 12, दो हाइड्रोजन के लिए 2 into 1 एंड एक क्लोरीन के लिए 35. So if you just add this up, 14 plus 35.5, it will be 49.5 grams. So we have now calculated the empirical formula mass from the empirical formula which we calculated and found out in our previous slide. So now simply we will put it in this formula, which is 99 divided by 49.5. Okay. So I hope this is okay. And if you cancel it, the value of N will be 2. So if you solve this, if you just multiply this with 2, then you will get 99. So our value of N is 2. So we have found the value of N over here. Now we know the value of N, we know the empirical formula. So using these two informations, we will just write our molecular formula, which will be C2H4Cl2. If you now calculate its mass, you will see that it will come out to be 99 grams itself. You can try and do the calculation yourself. इसलिए इसका mass already हमको provided था. So we found out the value of N, which is the common ratio from that, and we finally got our molecular formula. You can calculate its mass and you will find it that it is 99. So this was the entire question and we solved this using 5 steps. आपको ऐसे ही 5 मार्क्स नहीं मिलेंगे, आपको सारे स्टेप्स करने होंगे. That is why you are given 5 marks. So because of all these steps, these question contains a lot of weightage in your school exams. So I hope this question was very clear and I hope you have understood the steps which I have used to solve this question. We will see one more example like this. Determine the empirical formula for the compound having 15.8% carbon and the rest is sulfur. तो यहाँ पे सिर्फ हमको empirical formula निकालना है. हम molecular formula निकाल भी नहीं सकते क्योंकि हमारे पास molar mass given नहीं है. We need the mass to find out the molecular formula from an empirical formula. So since the mass is not given, we will just find out the empirical formula. पहले हम देखेंगे कौन से एलिमेंट है हमारे पास. कार्बन है, सल्फर है. परसेंटेजेस क्या है? 15.8% है कार्बन का एंड बाकी है सल्फर. द रेस्ट इज सल्फर. मतलब 100% में 15.8% अगर कार्बन है तो 100 माइनस 15.8% इज सल्फर, and we will find the empirical formula. If you solve it by making a table like this, it will be very easy for you and it will be quick also. It will be easy for the examiner also to check. So let us see this table. पहले मैंने एलिमेंट के उनके मास परसेंटेजेस के साथ यहाँ पे लिखा है. First element is carbon, which is 15.8, which was given in the question. Second element is sulfur, which is 84.2. ये 84.2 मैंने कहाँ से निकाला? I have simply just subtracted 15.8 from 100. टोटल हमारा ऑलवेज 100% होता है, 200%, 300% नहीं होता. सो इफ 100% में 15.8% कार्बन है, बाकी सल्फर है, तो सिंपली बाय सब्ट्रैक्टिंग आई हैव गॉटन द अमाउंट ऑफ सल्फर इन दिस क्वेश्चन. सो हमें परसेंटेजेस मिल गए. हमारा पहला स्टेप क्या था? परसेंटेज से मास में कन्वर्ट करने का. सो द मास, मैंने बताया था कि जो वैल्यू होगा परसेंटेज का वही वैल्यू मास का भी होगा, बिकॉज वी आर कंसिडरिंग 100 grams ऑफ कंपाउंड. दिस इज अ वेरी इंपॉर्टेंट पॉइंट. You will always have to consider 100 gram of compound. So the mass is 15.8 and 84.2 for carbon and sulfur respectively. Next step बहुत important, हमारा number of moles निकालना. To find out the number of moles, we will divide the masses with their respective atomic masses. तो कार्बन का atomic mass है 12, so we are dividing 15.8 by 12, which will come out to be 1.32 number of moles. And for sulfur, the atomic mass of sulfur is 32, so we will divide 84.2 by 32, which will come out to be 2.64. तो इस क्वेश्चन में मैंने यहाँ पे राउंड ऑफ नहीं किया है. आई एम जस्ट कीपिंग देम एज 1.32 and 2.64. Now we have to find the simple whole number ratio. Again, a very important step. So the simple whole number ratio हम क्या करेंगे? जो सबसे कम वैल्यू है उससे बाकी सबको डिवाइड करेंगे. तो यहाँ पे सबसे कम वैल्यू है 1.32. ऑब्वियसली 2.64 से वो कम है, तो इस वैल्यू से हम सारे वैल्यूज को डिवाइड करेंगे. So 1.32 by 1.32 is 1 and 2.64 divided by 1.32 is 2. तो मैंने यहाँ पे राउंड ऑफ नहीं किया था. अगर आप राउंड ऑफ करते भी तो इट वुड हैव बीन ओके, बट आई डिड नॉट राउंड ऑफ एंड वी गॉट अ होल नंबर रेशियो. आई हैव केप्ट दिस कॉलम ब्लैंक, क्योंकि अगर फिर से कुछ आपका डेसिमल पॉइंट में निकलता लाइक 1.5 या फिर 2.5, देन यू वुड हैव टू मल्टीप्लाई इट विद सम कोएफिशिएंट, बट हमारे पास यहाँ पे नहीं निकला है, सो वी विल जस्ट नॉट बॉदर विद इट. तो फिर से एक बार स्टेप्स को रिपीट कर लेते हैं. पहले एलिमेंट्स और उनके मास परसेंटेजेस लिखेंगे, वहां से हम मास कैलकुलेट करेंगे विच विल बी द सेम इन वैल्यू. उसके बाद हम नंबर ऑफ मोल्स निकालेंगे, वेरी इंपॉर्टेंट, बाय डिवाइडिंग ईच एलिमेंट्स मास विथ इट्स एटॉमिक मास. तो गिवन मास बाय एटॉमिक मास करके हमारा मोल्स निकलेगा. एंड इसमें से सबसे जो छोटा वैल्यू होगा, छोटे वैल्यू का मोल होगा, उससे हम बाकी सारे वैल्यूज को डिवाइड करेंगे. So this was the lowest value, so we divided this one and this one with 1.32 and we got our simple whole number ratio. कार्बन का रेशियो निकला 1 and सल्फर का रेशियो निकला 2. So finally our empirical formula for this compound will be CH2. So this is our final answer. We are just finding the empirical formula, so this will be our final answer. So this was another question जिसमें आपको सारे steps carefully solve करने पड़ेंगे and then you will reach the ratio and then you can just find the empirical formula. अगर molar mass दिया होगा तो you can find out the molecular formula also. Let us see another type of question. A compound has the empirical formula of CH2O. So a compound has the empirical formula of CH2O and 2 moles of the compound weighs 360 grams. Find the molecular formula. इस क्वेश्चन में आपकी मेहनत कम है क्योंकि यहाँ पे एम्पेरिकल फॉर्मूला आपको निकालना नहीं है, ऑलरेडी दिया गया है क्वेश्चन में, which is CH2O. So we have 1 carbon, 2 hydrogens and 1 oxygen in the empirical formula. और क्या एक्स्ट्रा इंफॉर्मेशन है कि 2 moles of the compound weighs 360 grams. So we have to find the molecular formula. So we will again use the relation, which is this one. n equals to molecular formula mass by empirical formula mass. तो पहले हम empirical formula mass निकालते हैं from the empirical formula. Empirical formula था हमारा CH2O, 1 carbon 12, 2 hydrogen 2 into 1, 1 oxygen 16. So we have 30 grams, which is the empirical formula mass. लेकिन यहाँ पे हमको मोलर मास नहीं दिया गया है, हमको थोड़ा सा उसको ट्विस्ट करके ये लिखा गया है कि 2 moles of the compound weighs 360 grams. मोलर मास क्या है? मोलर मास इज द मास ऑफ 1 mole of any compound. तो यहाँ पे 2 moles का मास दिया गया है 360 grams. So obviously 1 mole will be 360 by 2, which is 180 grams, and this is the molar mass. So this question is different. Why? Because यहाँ पे directly molar mass हमको नहीं दिया गया है, हमको 2 moles का weight दिया गया है. अगर 2 moles का weight x है, तो 1 mole का x by 2 होगा. So and that will be the molar mass, because by definition molar mass is the mass of 1 mole of any compound. So now we have the molar mass, we have found the empirical formula mass. We will just put it in this equation. 180 was our molar mass, 180 by 30, which was our empirical formula mass. If you just solve it, it will be 6. So हमारा n का value हो गया 6. So we will just multiply our empirical formula with 6 and we will get the molecular formula of C6H12O6. ये किसका formula है? ये है glucose का formula, which we studied in the previous slides. This is the formula of glucose. So we have found the molecular formula from the given empirical formula and the indirect molar mass. यहाँ पे directly molar mass नहीं दिया गया था, हमने उसको निकाला and then we just put it in this equation and we got the common ratio and now we have the molecular formula of glucose, which is C6H12O6. So this was another type of question जिसमें आपको सारे steps नहीं करने होंगे. Empirical formula से आप molecular formula easily निकाल सकते हो. Now these are some practice problems for you to solve. Determine the empirical formula of an oxide of iron in which the mass percentages of iron and oxygen are 69.9 and 30.1% respectively. तो यहाँ पे आपको सिर्फ empirical formula निकालना है. एक oxide of iron मतलब उसमें iron होगा, oxygen होगा. Obviously, I have mentioned iron and oxygen, and the percentages also I have mentioned. So you can just follow the steps and you will find out the empirical formula. Calculate the mass percentages of the different elements present in sodium sulfate. Mass percentages अभी तक हमने discuss नहीं किया है, so we will omit this question. A compound is found to contain 40% carbon, 6.7% hydrogen and 53.3% oxygen by mass. If the molecular mass of the compound is 60 grams per mole, what is its molecular formula? So this is again step-by-step process. कार्बन है 40%, हाइड्रोजन है 6.7%, ऑक्सीजन है 53.3% by mass. If the molecular mass is 60 gram per mole, then what will be the molecular formula? So this is another question for you to solve. So I hope this video has been informative. इसमें आपको पता चला कि empirical formula क्या होता है, molecular formula क्या होता है, उनका importance क्या है, and obviously how to find them out with given data such as this, जहाँ पे आपको elements और उनके percentages दिए जाते हैं, वहां से आपको कैसे ये सब निकालना है, we just found out. So this was our discussion on empirical formula and molecular formula. Thank you. Please join the world of Mentis Galaxy, जहाँ पे आपको मिलेंगे regular classes, engaging content in shorts and reels, and obviously we will solve your doubts in our problem solving sessions. I would like to request you all to subscribe to our YouTube channel and also visit our Instagram page for more fun content like this. Thank you for being a part of Mentis Galaxy. And if you are not a part already, I would like you to subscribe to our channel and visit our website. Thank you so much.